Okay, so this is Chapter 5, Section 2. This is actually the first one of the chapter. We're skipping 5.1. So in this one, we're going to be solving systems by substitutions. Your objective today is that you're able to solve a system using substitution. And we're actually going to cover another way first. It's actually what makes it 5.1. We are going to kind of quickly solve the system by graphing. And solving the system by graphing is nice in that you can kind of see where it should be. However, it's really easy to kind of have a bad graph and get the wrong answer from it. But we're going to go ahead and start here. Good draws. There we go. All right, so number one, we have y equals x plus 4. And we have another system that is y equals negative x plus 8. Sorry, another equation. So what you'll see is that we have two equations. You can actually do multiple equations, but we're going to keep it simple and just keep 2. So what we're going to do is we're going to take a graph, and I have a couple little hints here of where it's probably going to look like. I'd probably need to go up to 8, but I can also go down to the negatives a little bit. So I'm going to call this first one 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2. Okay. So, and then go across like this. Make myself a nice little kind of sketched graph. If you're doing this on graph paper, it's a lot easier to do. If you're doing on line paper, I definitely do not recommend using this method. Just that it's hard to actually see where they intersect if you're not using graph paper. So the way that we're doing this is we're actually going to do this with two kind of parts. The first one, we're going to do this first equation, and we're going to do it in orange. So we're going to go, so whenever I'm looking at this, this says y equals x plus 4. You should know from this point, this is in slope-intercept form. This 4 is the intercept, the y-intercept, so I'm going to go up to 4. 1, 2, 3, 4. I'm going to put a dot. And then I'm going to graph off of this. So if I plug in 1 for x, so if I go to 1, let's label this 1. I guess I'll label this 4. If I go to 1, then 1 plus 4 is 5. So I'll be at 1, 5. And then I'll do that again. It'll be 2, 6. 3, 7. And you kind of get the point, the idea here. And so we're going to graph a straight line. And I'm going to graph those 4. I might need to graph more as we go on, depending on kind of what happens here. Let's make the other one green, just so it is slightly more obvious. So we're going to make this one green. So y equals negative x plus 8. So this, again, this plus 8 tells me I'm going up to 8, so I'm at 4, 5, 6, 7, 8. Now my slope here is negative 1, so down 1, right 1, or up 1, left 1, kind of whichever way you kind of imagine that. So down 1, right 1, no matter your rise over your run. Rise, run, rise, run. And I draw a straight line. Now, because it's on a piece of graph paper, this is pretty accurate. I can actually make a pretty good estimation on what this is going to be. So this is going to be at, this is 1, this is 2, so it's going to be at 2, let's see, what is that, 6. So my answer is 2, 6. And what that means is if I plug in 2 to both of these, I'm going to get the same answer. And I can even prove this. So if I go, okay, so I think it's going to be 2, 6, so 6 for y, 2 plus 4, 6 for y, negative 2 plus 8, 6 equals 6, 6 equals 6. So both of these are the same thing. What we're looking for is where do they intersect and where are they going to be the same number. Okay. Let's do another version. So this will be number 2. If I have y equals negative x minus 3, and I'm going to just change colors right now so it's a little easier for you guys to see, and y equals 3x plus 10. I'm going to graph this again. Looking at my numbers, it looks like I'm going to need to go up to 10. So there's going to be, and down to -3. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4. And go straight across. I guess I should have done this in a different color. That's all good. You'll figure it out. So let's start with the green one. So the green one, I'm going down to -3, so 1, 2, 3, down 3. And this is a down 1, right 1, or an up 1, left 1. And I'll just put a couple points there, and then I'm going to go do the other one, which I unfortunately did in orange along with this graph. So I'm going to go up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a point, again, that's from this y-intercept. And the change here is a rise of 3 and a run of 1, because there's an invisible 1 under there. I'm actually going to go to the left-hand direction, so I'm going to go down 3, 1, 2, 3, and go left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. And I'm going to graph this out. So I'm going to connect these. And what you'll see, okay, come on. All right, fine. I'm going to go with this one on green too. Is that these actually don't meet up at a nice location. And that's totally fine. And that's actually an issue that we're going to have with your graphing like this, is we won't be able to sometimes be able to get it exactly. So technically, yes, there is. This is where they are. That's going to be at like, I'd probably even put it as like between, -3 and -4, and then it's in the positive-ish area, because this isn't a perfectly straight line. Okay. Let's do another one. Number 3. X plus y equals 3, and 2x minus y equals 6. That was a really bad y. Now, before we do this, what we need to do is we need to switch this so that it's in that slope-intercept form. And so I'm going to do the top one first, where I have this x plus y equals 3. I'm going to subtract an x from both sides, because I need to get rid of the x on this left side. I want y by itself. So I get y equals -x plus 3. Alternatively, you could write this as 3 minus x. That's totally fine as well. Okay, let's do green for the other one. I have 2x minus y equals 6. Kind of two ways you can go about this. Both are equally valid. For me, I might just say, okay, I'm going to bring this 2x over, and then I'm going to change the signs and everything. So I'm going to subtract 2x's from both sides. I get -y equals -2x plus 6. Now I still have this negative over here, so I'm going to divide everything by a negative. And so I get y equals 2x minus 6. All right, now I can graph this. Let's use like black to be the graph. So I need to go to -6, and I need to go to +3. So 3, 2, 1, 0. 1, 2, 3, 4, 5, 6. One more is 7. Okay, so let's start with orange. So orange, I'm going to go to +3, so 1, 2, 3, put a dot. Then graph my slope, which is down 1, right 1, or somewhat similar. Then what I'm going to do is I am going to start graphing that green one. So I go to -6, 1, 2, 3, 4, 5, 6, put a dot. And this changes up 2 over 1. So up 2, 1, 2 over 1. Up 2 over 1. Up 2 over 1. Hey, these ones actually meet up in a nice spot. That's good. And so the big kind of thing whenever you're graphing is just make it so that they're actually wind up kind of meeting together. And find that kind of general area that they meet. Okay. Let's do another one. Oops, I didn't tell you what the answer is. The answer on that one would have been, I just counted over 1, 2, 3. So the answer is 3, 0. X comes first. The way I remember that is X comes first in the alphabet. Okay, let's do another one. So this will be number 4. We have 5x plus 2y equals 2, and 3x plus y equals 2. So I'm going to write these again, and we're going to kind of solve for them. So I have 5x plus 2y equals 2. I want to get the y by itself, so I'm going to subtract 5x from both sides. So I get 2y equals negative 5x plus 2. Divide everything by 2. I get y equals, and leave these as a fraction. Don't try and change these into a decimal. It just makes life a lot easier. Plus 1. And we'll do orange. So I have 3x plus y equals 2. Subtract 3 x's from both sides. I get y equals negative 3x plus 2. Alright, let's go ahead and graph this. Looking at my numbers, I need to go to 1 and I need to go to 2, so I'm going to make it a pretty small little graph probably. Okay, so I'm going to go, let's start with the green one. So I go to positive 1. And then this is a chain, this is a rise of 5 and a run of 2. And you can go kind of the negative in whichever way you want to go. So I'm going to go up 5, 1, 2, 3, 4, 5, and then left 2, 1, 2. And then 1, 2, 3, 4, 5, 1, 2. Okay. Let's do the orange one now. Go up to positive 2. And I go negative 3, 1, 2, 3, like that, or 1, 2, 3, right, 1, 1, 2, 3. Hey, look at that. Those ones actually wind up hitting together, just like that. So if I draw a line, it's not going to be a good line. They're going to hit there. Then if I draw the other one, cross right here at negative 1, 2, 3, 4, negative 4, comma, nope, it's not. 2, comma, negative 4. X is first. Okay. Let's just do another one. That way you kind of get this idea of this. And on this one, go ahead and pause for a second right before we kind of go through it. See if you can do it on your own. So number 5, x plus y equals 7, and x minus 2y equals negative 5. See if you can do that for a second. Go ahead and pause this. I'm just going to continue on. So when we do this, again, we want to get that y by itself. So I'm going to go x plus y equals 7. I want to get y by itself, so I'm going to subtract x from both sides. So I get y equals negative x plus 7. For the other one, x minus 2y equals negative 5.
Subtract an x from both sides. I get negative 2y equals negative x minus 5. Divide everything by negative 2. I get y equals, that's a positive 1/2 x plus 5/2. Alright, gonna graph this. I need to go all the way up to 7 and all the way up to, that's 2.5. So I'm going to go down to probably like negative 1. There you go. 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1. Put a line going across like that. And like that. Alright, let's go ahead and graph the orange one first. You can do whichever one you wanted to do first. I'm just doing orange because. So I go up to 7, 1, 2, 3, 4, 5, 6, 7. Put my point. Look at my slope. It's negative 1, so it's down 1, right 1. Do the same thing with green. Up to 5/2, so 4.5 or 2.5. So 1, 2.5, and that's going to be kind of an approximation. Now the change here, you go up 1/2, which can be a little weird, or you can kind of think of it as if we're at 4, if we're at 4.5, if we add another half, we should be here. And from there, once I'm on this like actual intersection, that's when I'm going to graph this. So I'm going to go up 1/2. Just kind of makes it a little bit easier. You could, if you wanted to, put another one here, just increasing by halves each time. So these guys actually do intersect. They intersect at 1, 2, 3, 3, comma, 1, 2, 3, 4, 3, 4. Okay. All right, one more set of graphing, and then we're going to get into by substitution. So number 6. Y equals 1/3 x plus 6. Y equals negative 2/3 x plus 3. Alright, so let's kind of separate these out. So I get y equals 1/3x plus 6. This way we can see which color I'm using. And then green is going to be y equals negative 2/3x plus 3. Alright, looking at this, I see that I need to go at least up to 6 and down to at least 3, so I'm going to just go from, alright, 7, 6, 5, 4, 3, 2, 1, 0, negative 1. You don't have to go down to negative 1. I like to just because it gives you kind of that option if you need it. Alright, let's start with orange. So I'm going to go up to 6. 1, 2, 3, 4, 5, 6. My rise is 1, my run is 3, so up 1/3. 1, 2, 3. Or down 1, left 3. 1, 2, 3. 2, 3. Alright, now I'm going to go up to 3. 1, 2, 3. And my change is negative 2/3. So I can go down 2, 1, 2, and right 3. 1, 2, 3. Or I can go up 2, 1, 2, and left 3. 1, 2, 3. Hey, we have an intersection right here. And as you do these, you'll start to kind of get a sense of maybe where they'll intersect. So this one ends up intersecting at negative 1, 2, 3, negative 3, comma 1, 2, 3, 4, 5. You'll start to get just a feel of like, okay, this is either going to intersect over here, or down here, and you'll kind of get a general idea of where it might be. If you don't, that's fine as well. Okay. All right, now let's get into the meat of this. So the big thing that we're going to be kind of talking about, and this is kind of one of two ways that you'll really solve these systems, is by substitution. Substitution is nice in that it can be kind of a go-to especially if things are working out pretty nicely for you. So this is number 7. So y equals 10 minus 2x. And our other equation is x equals y minus 4. Now, hopefully by this point you kind of understand this concept I'm about to say is I can plug in 1 for x, like if I have a ordered system, if I have a pair and I say 1, 4, I'd be able to plug in 1 for both this x and this x. And we're going to utilize that idea in order to make, oh, that's really rough, in order to make this kind of work. So what we're going to do is we're going to say, hey, what this means is x, for anywhere that I see x, I can put in y minus 4. Because x is y minus 4. That's what this is saying. Like if we were to say this in words instead of an equal sign, this would say x is y minus 4. You could also go the other way of saying y is 10 minus 2x. And so we're going to use that idea. So if I have this y equals 10 minus 2x, instead of x, I'm going to take this and plug it in. So what happens is now I have y equals 10 minus 2, maybe I'll do this in orange just so you see that the substitution happened here, y minus 4. And you might be going, oh, man, I just don't quite get that yet. Let's go ahead and work through this, and then we'll show you how to check. And we can kind of verify that, yeah, this is true, this does work. So we go ahead and we're going to distribute this. So this negative 2 gets distributed to both these things. So we get y equals 10 minus 2y plus 8, because negative 2 times negative 4 is positive 8. Let me get rid of this little dash in here just so you don't get confused. Now we can combine like terms. So I'm going to go y equals 10 plus 8 is 18 minus 2y. We want to get the y's by themselves, the variables by themselves, so I'm going to add 2y to both sides. And I get 3y equals 18. Again, I need to get the y by itself, so I'm going to divide by 3, and y equals 6. Now this is the part where some people, they stop, they think, hey, I got a number, I'm done. Not quite the case. What we need to do is we need to figure out what x is. For me, whenever I'm looking at these two equations, because these are our two original equations, I know what y is, I want to find out what x is. If there's one that already has x by itself, I'm going to use that. So I go x equals y minus 4. And let me circle this in green just so you can kind of see where I get it from. So x equals, in green, 6 minus 4. So x equals 2. So my answer for this entire thing that we just did is 2 comma 6. Now, a good practice to get into is to always check, because sometimes you do this all right and it actually doesn't work, and we'll get into that in a little bit. So whenever we do this, we're going to plug things in. So I'm going to start with kind of, let's see, we had y equals 10 minus 2x. So y is 6 equals 10 minus 2 times 2. I got that from this equation that we had right here. We got that from there. So 6 equals 10 minus 4. 6 equals 6. Yay, it works. And just because it works on one doesn't mean it's going to necessarily work on the other, so we want to check that as well. So x equals y minus 4. So anywhere that I have x, I put a 2. Anywhere that I have a y, I put a 6. 2 equals 6 minus 4 is 2. Yay, it works out. Okay. Number 8. 4y plus 1 equals x. X equals 5y. Now looking at this, it might seem a little bit confusing because you say, hey, x is by itself on both of these. But remember, this is saying x is 5y, or 4y plus 1 is x. So what I'm going to do, and let me circle this one in green, so you kind of see the substitution that happens. We have 4y plus 1 equals 5y. Because this x right here, is this 5y, and this 5y gets put in for x. So now I can solve the equation. So I say, okay, I want to get my y's by themselves. I'm going to subtract 4y from both sides. I get 1 equals y. Ooh, that was a lot easier than that first one. Now, am I done yet? Well, the answer is still no, because I need to take this and plug it into one of these original equations so that then we can get a correct answer. And let me choose a different color. Let's do pink. So here's almost part 1 of the problem, if you will. And so I'm going to say, I like keeping my numbers simple. You can actually plug it into either equation, but I'm going to plug it into x plus 5y. So I have x equals 5, and then my pink times 1. So I get x equals 5. So my answer is 5, 1. If I plugged both of these onto a graph, they would intersect at this location. We'll make sure that it works though. So if I have 4y plus 1 equals x, I go 4 times 1 plus 1 needs to equal 5. 4 times 1 is 4, plus 1 equals 5. 4 plus 1 is 5. 5 equals 5. Yay. I'm going to do the second one as well. X equals 5y. X is 5 equals 5 times 1. 5 equals 5. Yay, it works out. Okay, let's do another one. Number 9. 5y equals 10, and x minus 3y equals 4. This one's a little more complicated, mainly because we don't have a variable by itself. And one of the equations actually only has one variable. Oops, undo. So what I'm going to do is I'm actually going to solve for this 5y kind of on its own so that I get y by itself, because I can do that. Because it only has one variable, I don't need other things to solve for it. So I'm going to divide by 5, and y equals 2. Let's circle that in this purple. And then I need to still solve for x. So x minus 3y equals 4. Now anywhere that I have y, I'm going to put in 2. So x minus 3, let's go to purple, times 2 equals 4. So x minus 3 times 2 is 6 equals 4. Add 6 to both sides. and x equals 10. So my answer is 10, comma 2. Now what we need to do is we need to check. First one's pretty easy because we already did that. So I go 5 times 2 equals 10. 5 times 2 is 10. 10 equals 10. I'd hope so. Then we have x minus 3y equals 4. Oh, I just realized I didn't do the original on this one. It was 5y equals 10. Sorry. So x minus 3y equals 4. So anywhere that I have an x, I'm going to put a 10. Minus 3, anywhere that I have a y, I'm going to put a 2. Equals 4. 10, negative 3 times 2 is negative 6. Equals 4. 10 minus 6 is 4. 4 equals 4. Checks out. Number 10. Go ahead and try this one once we have it written out. Just pause the video and try it. See if you can do it on your own. I'm not going to pause personally, just so you can continue on once you're ready. So at this point, go ahead and pause it. Try it out on your own. See how you can do. So whenever we're doing this, again, we want to try and get a variable by itself. Me personally looking at it, I like this one. This looks nice. Nicer. This looks nicer than this one. So I'm going to solve for one of these variables, and you can choose either one. Let's just solve for y. So let's get y by itself. So I have x plus y equals negative 2. I'm going to subtract x from both sides because I'm trying to get y by itself. Y equals negative x minus 2. You could go either way. It doesn't really matter. Okay. Let's circle this in purple. I think I can actually have two colors. Oh, yeah. Okay. So now I'm going to plug this in to the different equation. 2x minus negative x minus 2 equals 14. So I distribute this negative and I wind up with 2x plus x plus 2 equals 14. Combine like terms and I get 3x plus 2 equals 14. Subtract 2 from both sides and I get 3x equals 12. Divide everything by 3. I get x equals 4. I still need to get y by itself, or solve for y, so I'm going to use this x plus y equals negative 2. Let's change this to green. So I have 4 plus y equals negative 2. I'm going to subtract 4 from both sides, and I get y equals negative 6. So my ordered pair is 4 comma negative 6. Now we want to go in and we want to test that. So if I have x plus, we'll put check above this. There we go. X plus y equals negative 2. My x is 4 plus my y, which is negative 6, needs to equal negative 2. 4 plus negative 6 is negative 2, so negative 2 equals negative 2. Yay, it worked. Now we also need to try it with the other one. 2x minus y equals 14. So I go 2 times 4 minus negative 6 equals 14. So 8 plus 6 equals 14. 14 equals 14. And that's a true statement. Okay. Number 11. Asks us to describe and correct the error in solving for one of the variables in the linear system, negative x plus 4y equals negative 9, and 3x minus 2y equals 7. So, if we have, so these are the two equations, so negative x plus 4y equals negative 9, and the other one is 3x minus 2y equals 7. So what they have listed here is, for step 1, they have negative x plus 4y equals negative 9. And they have negative x equals negative 4y minus 9. Step 2. They have 3 parentheses negative 4y, apologies, minus 9 minus 2y equals 7. Then we get negative 12y minus 27 minus 2y equals 7. We get negative 14y equals 34. And then we get y equals negative 17 over 7. Take a moment, try and see if you can find out what the error is. Maybe you kind of got it whenever I was reading through it. The issue, I guess what's wrong, the issue that they had is they didn't get the x by itself. So x isn't alone. It has the negative in there. So we need to divide slash multiply, whichever way you kind of think about it, by negative 1 in step 1. And that'll get you the right answer. Okay. Finally, for this one, number 12 asks us to write a system of linear equations that has the ordered pair as its solution, and it gives us the ordered pair of 1, 4. So what that means is that we need our x to equal 1, and we need our y to equal 4. Now, I'm a very kind of firm believer in keeping it easy on yourself. So when I look at this, I say, okay, how can I go from 1 to 4? Well, if I go 4 times 1, I'm going to get 4. So I could write that as 4x y. So there's 1. And then I could also write, okay, what's another way that I can get from 1 to 4? Well, I can go 1 plus 3 equals 4. And so I can go x plus 3 equals y. And now you have two equations, and you would write these. You could go 4x equals y, and x plus 3 equals y. That's kind of an easy way to it. Okay. Hopefully this is helpful, and go ahead and check out your assignments from your teacher, and have a good time.